So the technology that we are working on has to do with a security system for mobile ad hoc networks. It's just nodes talking to each other, much the same way in which you talk using walkie-talkies. Ad hoc networks are inherently vulnerable to the attacks, and because of this vulnerability, it's been difficult to get them fielded and accepted because nobody wants to field a system that could potentially become corrupt. And particularly in the military, they're concerned that if one of their radios in their systems gets captured, essentially the rest of the network can no longer be trusted. The same is true in vehicular ad hoc networks, where you'll have vehicles who are communicating information to each other about, for instance, road conditions, maybe their state. There's some programs called emergency brake light, electronic emergency brake lights, where a car far in front of you may have an emergency situation and is slamming on their brakes, but because they're out of your line of sight, you don't see that. But what vehicular ad hoc networks does is that it relays that information back along the road so that you get early warning that something may come up. The goal is to observe and prevent and then cure. It gives us the ability to understand an entirely different level of what's going on in the network. And this gives us a unique position to be able to identify that when something goes wrong or when something goes bad, we can identify not only where it went bad, but we can identify what the impact will be overall through the network. But also the reverse is true. Whenever we observe something going bad overall over the network, then we're able to go back and find out where it went wrong. This could enable the widespread use of these networks under those circumstances, given the more intelligent and more aggressive and more sophisticated kind of attackers that we're facing every day. I'm Gavin Holland, and I'm the co-inventor of system and method to detect attacks on mobile wireless networks based on network controllability analysis.